have the honor to introduce our last speaker. This is James Witherspoon from Zebra Technology Corporation. And your presentation is using barcode reading and machine vision to create deep learning solutions. And I have to say I'm really interested to what this combination will bring us. And yeah, the stage is yours.
Oh, well thank you very much. Yeah, is this on? Can you hear me? All right. Well, thank you very much. As mentioned, I'm Jim Witherspoon from Zebra Technologies. I've been in the industry for 20 years and I come from Detroit, Michigan, so it's great to be here today. According to my heart rate sensor, I'm very excited to be here. So it's funny how these things work. It went off on the desk, I'm like, what's my wrist buzzing for? It's like, your heart rate's really high. Well, I'm just really excited to talk to everybody today. So thanks for having me. I haven't felt this much excitement in this industry in a bit, mainly probably because we've all been working in our basements, but just coming back to a show and seeing all the new faces and all the new companies and all the new booths, it's very exciting. And a lot of that has to do with what you're hearing about today and what these two gentlemen talked about is deep learning. So I knew that this industry was going to change a little bit when I have a 9-year-old daughter and she came home from school and she was in a STEM class, which is like a science education and all those sorts of classes. She comes back and she says, Daddy, I know what you did now. We talked about it in school. And I said, what's that? She said, oh, we got these machines that could think like humans and do those sorts of things. And I was, oh, that's really cool. Because usually she would tell people that my daddy reads barcodes and checks to see if the top is on the water bottle, right? So that's not very exciting. So at least I got that going for me. I'm cool now. The technologies we talk about and do, so you can all pat yourself on the back. We've really made it to the mainstream. But today, this is an interesting topic. People are like, how can you tie in barcode reading with deep learning? Those are on complete different ends of the spectrum from each other. So today I'm going to tell a little bit of a story about the company that's actually done it, how they've changed some ways about some of their processes to go ahead and do that. But to get started, I'll share a few terms with everybody. So when I talk about fixed barcode reading, it's going to be image-based barcode reading. So all you laser people who like your laser rastering scanners, I'm sorry, this topic isn't quite for you. We're going to talk about the image-based, where I'm going to capture an image and I'm going to read some barcodes off of it. The second one I'll define here is going to be machine vision. So think standard rules-based, traditional machine vision-based systems, object locate, blob tools, those sorts of things. And then finally, what these gentlemen talked about, the neural network and some of the deep learning, some of those subjective types of applications that you've heard about. Just wanted to define those for everybody really quick. So on this slide, I'm going to talk about a company that's a manufacturer. And part of this manufacturing process, there's a little group within inside this company. That group is the part that packages everything up, ships it all up, and gets it out. Now, if you're familiar with that type of group, that group never gets money. They never have funding. They never have these fancy PLCs and all these cool pieces of equipment that they have to deal with. So it's kind of funny that this group, which has the littlest amount of automation, the smallest budget, actually changed the entire way this company thought about barcode reading and fixed industrial scanning. So it's really cool. On this slide, you're going to see what they did. They went and they ranked all of their applications. They said, here's everything we want to do. So on the left-hand side of the slide, you're going to see that there's a barcode read, right? That's about as simple as you could get with machine vision and imaging. I'm going to take a picture, I'm going to read a barcode. Then they might do something like, check the quality of the code. Maybe they need a little bit more resolution for that. And then they also could do things like OCR or package validation, make sure that the barcode matches it. That might be more of your machine vision, traditional things, where you would apply a smart camera to that. And finally, they even dove into and tried to do some deep learning out of the gates. So they were trying to do some package quality inspection to see if they could do that, and didn't have much success with that. But I'll tell you how that story ends. It's a good ending, so don't worry about it. So in the past, each one of these circles you see on the screen would be handled individually. So the group would come in and say, hey, I need to read a barcode. Well, what they would do is they would just grab some VGA 640 by 480 sensor, put it out there, and start reading a barcode. And they would call it a day. Hey, we're doing our job. We did it. This is great. The next opportunity come in and say, hey, we need to grade this code. It's not reading really well. So they'll, like I said, they'll put a 1 megapixel on there. Then someone says, we need to do some OCR applications. They grabbed a smart camera, popped it on the line, started doing some OCR applications. So you can see how each one of those things, nothing was related, nothing was interjoined yet. If you talk to them at that time, they would tell you they're getting by. Things are okay. We're solving all of our applications. We're getting parts out the door. Quality's good, all those sorts of things. However, this pandemic thing hit them, right? And then they're having a really rough time with the human capital. They can't find people. they can't maintain people, and they can't hire people fast enough. So when you're in a manufacturing environment, it's very important to manufacture, right? You have to make parts. The more parts you make, the more money you make. Well, they were doing a lot of other things, and they didn't have the resources to be able to do that. The second thing that hit this company was that they have a high demand. So their products actually increased in need during the pandemic. So that's another two things. That's two really bad things that have happened to you. You need people, you can't get them. People want your product and you can't make them. So they needed to do something. The first thing they thought about is automation, and that's really the story of automation, how you could do things better and make things easier for people. Get more out of their automation. That was what they decided to do and go after. So they looked at it and they decided a few things. They go, the first thing we need to do is adapt deep learning. We need that technology. We have people who are standing there looking at boxes when they're going out and saying, yes, this box is good, no, this box is not. We need to free that human capital up to be able to take it and put it in our manufacturing process. And they said that they could do that with a lot of different applications that they have, but that was what the main purpose is. So they knew they needed to do that, knew they needed to go to the deep learning. The other thing they needed to do is do more automation. So it was nice they had some traceability and some good things going on with their traditional systems, but they had to get better visibility and share it across different departments and share it across different plants. So there's a bigger need for them to do more with machine vision, barcode reading, and you'll see more with some deep learning as well. So they came up with two questions. They wanted to know what they could do today to future-proof their investments for the future, and they also wanted to know what they could do with the stuff they had today. They've obviously, you can see here, they've done a lot with these technologies, how they could capitalize on that and move that forward. So what they decided to do is they came up with three things, and the first one is something that's new with these age. We've heard about IoT for the last 5 to 10 years. Everyone's probably sick of hearing about it. Yeah, everything talks to the cloud, but this company actually decided to implement it. They said, we're going to take every image we could possibly get, and we're going to shove that thing up in the cloud. We want to save everything from a barcode read to every quality inspection that we're going to do. Now, the reason why they're not doing this, obviously people are going to say, well, why don't you just do that locally? And that's because it doesn't scale, right? There's not a lot of IT people out there still, right? So if you put a giant server in there that needs backed up, and all of a sudden you're sending thousands of cameras worth of data to a local storage system, it just doesn't scale and it doesn't work right for them. Also, the cost of storage of the cloud has come down. So their ability to store mass amounts of information on the cloud was great. And they also finally bought off on that the cloud is relatively safe, right? Everything's hackable, but the technology has improved enough where the cloud has become a great place for them. The second thing they decided to do was over-spec applications, right? So this sounds like something you wouldn't do in the past, but it's definitely necessary today. So remember I talked about the barcode read. That's 640 by 480 imager. That's great if I want to read the barcode, but can I put the 2 megapixel camera out there and can I take a picture of the entire top of the box? And that's what they did. So they increased their resolutions on all of their devices. They said every new device that's going to go out there is going to be a 2 megapixel or 5 megapixel or beyond sensor. That way I could take a picture of the entire box and use that picture later on to create some of my deep neural network type systems. Thirdly, they decided to look at the actual technology that they're using. There's always this battle between IoT, or IT and OT. IT is your infrastructure, your server people, they make sure your virus protection's up to date, and then you have your OT people, which are the people who do your PLCs and all those sorts of things. They don't get along, they usually fight each other, they probably hate each other, they might send Christmas cards, but outside of that, they don't talk and get along very much. So they want to look for devices that satisfy each one of those needs. So think about things with dual Ethernets. So they're going to start implementing systems, a smart camera, a barcode reader that has one system that comes out and talks to the IT network where I can store my images, and the other one that's going to send the data to the actual cloud. So, or to the actual control system, if you will. So those are the three things that they decided. So every application they look at now, they look at those three things to try to do it. Now on this slide is an application. This is probably one of the hottest barcode reading applications that's out there in the market. It is called the overhead scanner, that's what we call it, right? So it's basically, in the past, and hopefully none of my counterparts who do the handheld scanners are here, people would use handheld scanners, and what they decided is that's not ergonomically good and the throughput isn't that great, so they're going to my product, which I really like, and doing an overhead scanner. It's basically this gentleman's going to pick a part up from the pallet or he could do it the other way from the conveyor belt. He's going to swipe it underneath and put it onto a pallet, right? And while he swipes underneath, there's a scanner above that's going to read it, right? So you're going to say, wow, that's really cool. What does that have to do with deep learning, right? Well, here's where you can start connecting the dots. So on this particular label is a lot code, right? And if you use traditional OCR type systems, it handles some variation, right? I could see some pitch, or if I'm, some scaling differences or some angular rotations it can handle. But think about this, if I have someone who's short in stature and I'm swinging the box underneath, those codes are going to be really tiny. If I have someone tall like Dirk Nowitzki, he's going underneath it, it's going to be, box is going to be up really high, and then those OCRs are going to be really large. And then you're going to have people who bring the package in on a 45-degree angle, or bring it in on a different angle. The traditional OCR style systems don't handle that very well. By saving each one of these pictures, each one of these images of the barcode, they were able to create an OCR model that handles all of their use cases. Pretty cool, right? I mean, who would have thought, man, barcode reading, saving images to the cloud, deep learning. They put it together, so it's kind of cool. So I wanted to share that particular use case with everybody. So the same company has another mundane barcode reading application, right? Reading the side of a box and reading the barcode on it. Again, they usually would use the 640 by 480. Remember I told you they tried deep learning. So they went in here and they took a bunch of pictures of the boxes on the side. They tried to build a network. It was hit or miss, right? They didn't like how many images they had to put in. They had to duplicate and put a second system in to capture those images. It didn't really lend itself to be a great experience for them. So what they did was they put a 2-megapixel scanner on the side of it because they know they had to read the barcodes. Again, they saved all that information up into the cloud. So when they did that, 14 days later, they had enough images where they could create a neural network that could look for scratches, dings, and dents on the side of their box. So they took an application that they know they needed to solve, barcode reading, saved those images to the cloud, used those images in the cloud to create a deep learning solution to look for scratches, dings, and dents. Remember I told you there was a shortage of people there. It was hard for them to keep these systems running, yet alone manufacturing going. They were able to take the people who were doing the inspections of the boxes, move them to their manufacturing facility, and now they can produce more parts and keep that up and running. So a huge win for that particular company based off of this, this presentation, the slides, right? It was very successful for them. Storing images sounds great, but there's also other things that they can take advantage of while doing it. You can see here they're able to track and trace at a deeper level and share that information across the different levels of the company. That's something that they decided was very valuable. If somebody has a problem over in a different plant, they could call them up and type a number in and see what the part looks like and those sorts of things. So other benefits of actually saving this information to the cloud. The second one here is very interesting. It's called proof of quality. So they OEM, this company OEMs and sends parts to someone else who puts it in their parts and then ships it off. So a lot of times they get a couple calls on the phone a couple times a month saying, hey, this part you sent me isn't built right. It's missing X, Y, and Z. Well, this company, as I showed you, it does a lot with machine vision. So they're like, I'm not so sure, right? Well, now that they've saved every image to the cloud, they also created a portal for their OEM. And they said, hey, every time you have a problem, go to this website, type that number in, and you can look and see what that picture was before it left our facility. And if it looks like it's complete, don't call us up and tell us something's missing. Obviously you broke it in your process. So I'm sure they didn't say that as bold as I just made it sound. But again, that's another value you could have just by storing images and doing that sort of thing. The rest of this slide talks about monitoring and fault checking and updating, all that. Once your devices are all cloud enabled, you could update firmware, you could manage it, you could see which devices are properly functioning, the read rates of those, you can see grades of those barcodes, and you see how the rates are going. So that's kind of the other things you get as a benefit with the cloud. And finally, why synchronize with the cloud, right? I told a couple stories here. One of them was no duplication of efforts. If I know I could solve something today with higher resolutions and I could read barcodes, send that information to the cloud, I don't have to put a duplicate system in or put another system in to start capturing images and doing those sorts of things. I could kill two birds with one stone, if you will, right? Their message, I would say, to everybody would be, is think about it. Like as you're leaving the show today, right? If I had all these images from all the years of stuff I've done in the past, could I create neural networks? Could I do different things with it? And the answer is probably yes. You could probably think of 100 things you could do and say, man, I really like to check for scratches on that particular image, or I really like to do this with that particular image. You're going to find a lot of reasons, a lot of things to do. A lot of the technology that people have purchased today have that capability that no one's taken advantage of. Check it out. I guarantee you it's worthwhile. It's a worthy investment to start keeping these images. If you talk to some of the guys who are up here today talking, or talk to some of the AI companies here today, having images is king when you're creating these models, whether to make them, to train them, to make sure they're going to work and function to your exact needs. So it's very critical to have those images. Start using the systems that you've invested in today. And don't forget to overspec, right? Start using some of those technologies. The costs of them have come down greatly over the past few years. The processing speed of them has gone way up. There's a lot more you could do with higher resolution systems today. So I guess that kind of ties in the story, right? How can you take a barcode reading system and create some deep learning pieces of it? Hopefully that makes sense or resonates and you guys could start thinking about that. But I just wanted to share that with you. I thought it was interesting, right? When we were putting in some of these topics for these calls, people are like, well, how do you put it together? And just like you said, like, how do you do that? So this is the kind of example of a real company that's actually done it and they've had some success with it right out of the gate. So I just wanted to share that with everybody and thank you for your time. My heart rate is now down, so that's really good. So if anyone has any questions, you can feel free to ask. I'm over at the booth, at Zebra booth, if someone has questions, or if you have questions, I'm good to go as well too. So thank you, everybody.
Yeah, thank you very much, Jim, for this inspiring presentation. Yes, well, I don't have a question on my panel, and I don't have a specific question to you, but I enjoyed it very much to see this combination, and I have to say you perfectly answered all my questions from the beginning. And also I found it very interesting to see how these machine vision could give benefits to the customers by accessing all these images and results. So it was very inspiring.
Great, thank you. Thank you, everybody.
Thank you.